If you're developing a Web3 application, at some point you will need a solution to scale, and we recently launched Engine Cloud, the ability for you to execute backend on-chain transactions with almost no setup and a simple HTTP API. Engine Cloud gives you access to server wallets. These are backend wallets that are 100% non-custodial and really powerful because they are based on Vault, our new key management system that is based on Rust, super performant, and end-to-end encrypted. With Engine Cloud and these wallets, you can perform concurrent transactions. That means that your user base can send hundreds of thousands of requests to Engine Cloud and you will be able to scale seamlessly. And on today's tutorial, I'm going to show you how easy it is to set up a new Engine Cloud service, and we are going to apply that to our real-world application. We are going to build a RWA real estate service, allowing a real estate agency to tokenize properties on the real world and the ability to verify those properties for compliance. The important part here is that the real estate agency workers are not going to need to sign any transaction because all the on-chain activity is going to happen on the backend. And I hope you use this project as an example on how you can integrate Web3 technologies into traditional services. So I hope you're hyped, go and get a cup of coffee and get ready because we are just getting started. Okay, so let me show you first how you can create your own engine instance. Let's create a new project here in your Thirdweb dashboard. I'm going to name this engine demo. For now, I'm going to allow any of the domains. Of course, you need to set up this to proper security measures when you are going to actually develop an application, but for demo, let's set it to unrestricted web access. Let's proceed. This is going to generate a client ID for me and a secret key. These are really important, so don't forget to copy and paste them on a secure place. I'm going to confirm that I securely stored my secret key and view project. And here we're going to have your project view, same as always, but now you can go to this new tab called Engine, and in differentiation of dedicated engines, now we have Engine Cloud. And here the first step is going to be create a Vault admin account. As I said in the introduction, Vault is our new key management system, which is ultra secure, based on Rust, and end-to-end encrypted. So let's create a new Vault admin account. Again, same as when we created the project, this is going to create an admin key. We need to copy as well. I'm going to confirm this and hit on close. And once I have it, once I have my Vault created, I'm going to create a new server wallet. I'm going to call this my wallet, for instance. And as easy as that, I created a new wallet. As you can see here, we are going to have the Vault Access token. This is really important because with this token, we are going to be able to access all the wallets on this Vault. And here we have our first created wallet. And by default, we have the base Efolia testnet. So we can perform our first transaction. This is going to automatically create a transaction ID because all the transactions are going to be queued. As I said, this will allow your users to send hundreds of thousands of requests to the backend at the same time, as all the transactions are going to be queued and each one is going to have its own ID. After some time, the transaction was confirmed. We can open this and check it out. And as easy as that, if you check, was 3 simple steps. We just created our first implementation of a Vault and created our first server wallet. We can check the API Explorer. By default, I recommend you to use the Thirdweb SDK. The reason is because with this SDK, you are going to have access to the rest of the Thirdweb services, such as extension functions, contract call, and account, without mentioning that setting up this is really easy. However, if you don't want to use the SDK, if you check the curl presentation, you are going to see that this is really easy. All of the requests are post request, and the only thing you need to pass is the secret key and the Vault access token. And then you can check the API reference to see how to interact with contracts, sign transactions, read contract data, and see the historic transactions your Vault and account is performing. You can do this for JavaScript, Python, Go, and C#. So no matter which programming language you are using, we support the most popular ones, and you can send the request to interact directly with these server wallets. For this tutorial, we are going to be using the Thirdweb SDK as we are going to be building a frontend as well. So to make the connection as smooth as possible, we are going to keep using the SDK. Here you are going to have the information of the server wallets. As you can see, this is the one we created to send the first transaction. And actually for this project, we are going to be using two. One, which is going to be the main account or the admin account. And the second one is going to be the verifier account. Remember, we are going to create a RWA real estate system, and we are going to have a different wallet to verify the properties. So I'm going to say verifier, and I'm going to hit on create. And as it says that, we are going to have two different wallets. Really easy, right? And then we have the vault, and here we are going to have access to your admin key. In case you forgot your admin key, you can just rotate this and generate a new one. And once you generate a new one, your access token is going to also change. And yeah, that's it. This is the summary on how you can create a vault really easy. And if you go to the transactions, after a small reloading, you're going to see the amount of total transactions performed, the total gas spent, and the daily transactions information you can export as a CSV. Finally, the only thing I want to require from you on this step is please go to server wallets and don't forget to copy these addresses because we are going to be using these during the tutorial. With that said, let's jump to the coding section. So let me show you how the project is going to look like. As you can see here, we have a really simple landing page. We live on the era of vibe coding, so I'm sure you can create a better looking interface than this one, but this is just for showcasing purposes. The important part here is we are going to have the list of the properties available and the state of the bidding on that property. So for example, if I go to the admin panel, I'm supposing I'm working for a real estate agency, so the user is going to have an interface similar to this one. I need to set up the property image and I need to send the property document. As we are trying to tokenize this real world asset, I need the actual deeds of this property. I created a mock PDF here with the deeds. I can set up the name, a nice description, and the rest of the information for the property, such as where is the property address, what is going to be the price, let's say 3 ETH. I'm going to say the square meters are going to be, I don't know, 300. And here I need to set the legal identifier. No matter on which country you live, each property should have its own legal identifier with your local government. So here you have the ability to put that specific ID. For this, I'm just going to make up some information and that's it. So if I click on create property, this is going to start processing. And as you can see here, after a little bit, I'm going to have this transaction hash. And I didn't need to sign any transaction because all this process has been made by the backend wallet or the server wallet. So if I go to the properties tab again, I'm going to see that new property over here with the information. And if I click on view document, I'm going to find the actual deed here. So if I'm working for a real estate agency, I can approve or disapprove this information. So let's suppose I'm a seller, I want to sell my house and I send this information. The real estate agency is going to verify that the documents are actually correct and to be aligned with compliance, depending on the government and the country the property is based on. And then if everything's fine, the real estate agency can actually approve or verify this property. So for example, this property over here, I can go back to the admin panel and I can verify the property over here. As you can see here, we can see the verifier wallet address. This wallet address is a secondary backend wallet, the one I asked you to create, that is going to act as a verifier. Before this wallet is able to verify any property, it needs to be set up over here. So the admin or the creator of the contract needs to add a new verifier. So I can just say I want to verify the property with the ID number 4 or the one we just created. I'm going to hit on verify property. Again, this is going to trigger a backend on-chain transaction. It doesn't require me to sign anything because everything happens on the backend. And if I go back to the properties tab, you are going to see that this property is now verified and has this check mark over here. So what we are going to be building is the smart contract responsible for creating these assets, these tokens, and all the functions required to verify the properties and add new verifiers. After that, I'm going to show you how we can use that smart contract and using the SDK, perform these backend transactions, and I'm going to also give you the basic setup for do it on the front end. And finally, you are going to find this final template for you to use as reference or as a base for your own project. So let's get to it. A small disclaimer about this project is that today we are going to be building a smart contract, which is going to be really simple but powerful and is great for a single entity or a single company, in this case, a real estate agency. It's great for the agency because they are going to have the total control of the smart contract, and they are going to be the only ones responsible for verifying or denying the authenticity of the properties. That also means that they are the sole responsibles to be compliant to the legal regulations on their country and also to maintain the entire system. However, some people may argue that this approach is heavily centralized and you need to trust the agency and the workings inside the agency to perform in good faith, which somehow can go against the nature of smart contracts because these are decentralized trustless agreements. A more decentralized way to approach this problem would be using a Oracle service such as Chainlink, using some sort of on-chain synthetic collateral and make the process more decentralized. However, this setup is more complicated, so you need to decide which one you want to address. Have more control but needing to centralize more your service, in this case trusting a real estate agency, or make it more decentralized using some service such as Chainlink functions. Today we are going to focus on the approach number 1, but if you want to learn how to do this in a more decentralized way, please let us know in the comments and we will be sure to create a specific tutorial about that. With that said, let's create our smart contracts project and let's see the game plan. So here I am on my terminal on a new empty folder. Let's create our project. So this project is going to be using the Thirdweb command line tool. So I'm going to say npx Thirdweb create contract. This is going to create a base contract for me. This first is going to install all the dependencies required. So let's wait a little bit. We need to select the project name once the dependencies are installed. Let me put myself on the other part of the screen so I'm not blocking this. And this is going to be called RWA contracts for real world asset contracts. I'm going to be using Forge or Foundry. I'm not going to use any basic contract. So let's hit enter and wait until the dependencies are installed. Once this is done, I can move to that folder and I can open my code editor here. We live in the era of AI, so I'm going to be using cursor, so cursor dot, and this is going to open the code editor here. Let me put this on the screen properly and make some zoom for you to be able to watch it properly. Let's first then delete the basic contracts created over here because we are not going to be using them at all. And here I'm going to also remove all the information inside of the README MD, and I'm just going to declare here the game plan. So we need to create a contract for the real world assets properties. So first, these are going to be a ERC 721 contract. We are going to be actually creating a new NFT out of these properties, and we need to set up some important steps here. So we need a way to add or remove verifiers. These verifiers are going to be other wallet addresses. As we are going to be managing everything on the backend, one of these verifiers is going to be the second wallet we created. Then we also need to create more functions to actually verify the property. After the person responsible checks all the documents and the compliance information, I'm going to also add some bonus functions to request buying the property. We are not going to be using this on this tutorial, but I'm going to leave these ones for you to use then this smart contract as template for your future projects. And of course, we need to set up some getter functions. So just because we are going to be able, to get and retrieve that information out of the blockchain. For that, let me go back to my terminal actually over here. Let me clear this and I'm going to install some dependencies. So I'm going to say forge install and I'm going to install the Open Zeppelin contract stack. As we install the OpenZeppelin contract stack, we need to go to the foundry.toml and set up some remappings over here. And actually this remapping is quite correct. I'm going to say that each time that I say add OpenZeppelin, is going to go to leave OpenZeppelin contracts, which is exactly what I want. So here on the SRC folder, we are going to create a new contract called Real Estate RWA.sol. I'm going to declare the license using MIT, and I'm going to use this basic setup, but this is not going to be a ERC20, so I'm going to remove this for now. It was just the auto completion working for me. I want to use one of the latest versions of Solidity, so I'm going to use 0.8.25. And I need to actually here declare the imports. So we are going to import the ERC721 enumerable for OpenZeppelin and also the ownable library in order to make this contract to be owned by someone. In this case, the owner is going to be the deployer address, the address we have on Thirdweb, and then we are going to transfer that ownership to the backend wallet. So the backend wallet is the responsible for creating and listing new properties. I'm going to say import ERC721 enumerable from @OpenZeppelin token extensions ERC721 enumerable.sol. And I'm going to also import ownable from the same library, OpenZeppelin contracts access ownable.sol. So my real estate, and estate is spelled with a E actually, so I'm going to change this here and here just to be coherent, real estate. So now that we have these imports, our real estate contract is going to be a ERC721 enumerable and is going to be also ownable. We are going to have a problem right away here because ERC721 enumerable requires some constructor parameters we need to implement. Here we have two options actually. If I just remove this, I can just set up a constructor using a ERC721. So I can say constructor ERC721 and send here the information. So for example, I'm going to say real estate token and the parameters are going to be RWA real estate or whatever. And I can just send here and say this contract is ownable and I can leave the parameters empty. However, if I do what I did at the beginning and I import ERC721 enumerable, then we are not going to have access to ERC721. So I need to actually import that as well. And that's it, we are going to have it. Doing this is more efficient because you are importing exactly what you need, but just take in consideration that for future implementation. And as you can see here, our contract is happy with us. So technically I can just go back to my terminal and clean it and say forge compile. And this actually compiles. So we have a working ERC721 enumerable contract, which of course, if we open this, we are going to have all the functions we imported from OpenZeppelin. Now that we have this base contract, we need to start thinking, okay, how can we make this align to our project? And as I show you on the demo, we need to create these functions to verify the properties. So let's do that. So this is going to be actually really easy. First, let's create a function to add a new verifier. And I'm going to say here function verifier. This is going to be, of course, only owner because our contract is ownable. And the only thing I need here is to add a new mapping. I'm going to say approved verifiers and the verifier address and I'm sending as parameter. Of course, it's mad at us right now because we don't have this mapping. So I'm going to over here create all that information. So I'm going to say mapping public approved verifiers is going to go from an address to a boolean. So I'm going to say that each time I use this add verifier, I can add a new wallet to be approved to verify the properties. And of course, I need to create another function to remove the verifier in case that wallet is no longer be able to verify a property. Now that we have the verifiers, let's add the functions to create or list a new property. So for that, I'm going to say this function is going to be called create property. I'm going to use some parameters over here. This function is going to be external only owner, and is going to return uint256, which is going to be the property ID. Here I need to set up what are going to be the attributes of that property. So I'm going to just copy and paste the ones I already set up for this project. We are going to use the property address, the price, the square meters, the legal identifier, the document hash, and the image URI. The legal identifier is going to be the unique identifier provided by the government. The document hash is something that we are going to be uploading to IPFS, same as I showed you on the demo. We are going to upload the deed using IPFS, and that hash is the one we are going to store on the smart contract. And of course, the image URI just to have the image of the NFT. Here, let's add the logic to create a new property. This is going to be really easy because what we need to do is, well, mint a new NFT. So the first thing I need to do is add one to the token ID. So I'm going to say token IDs plus plus. And I don't have this token IDs variable over here. So I'm going to go back to the top, and here I'm going to add that uint public token IDs. But on a second thought, I think that this should be private because the only ones accessing this information should be the actual real estate agency. So let's change the access to private. Let's go back over here, and I'm going to say that uint256 new token ID is going to be equal to the actual value of the token ID. So for example, if the last token ID was, let's say 1, this new token ID is going to be 2. That's why I'm storing that on a new variable. Then I'm going to call the function saveMint, and here I'm going to use the owner, which is going to be the one of the creator of the contract. And I'm going to send that new token ID to mint a new NFT. Then I'm going to add the properties to a new properties mapping. So I'm going to say properties with the new token ID is going to be equal to a new property object. We don't have either the properties mapping or the property object. So again, we are going to go back here and let's create first a struct for the property. The struct is going to have all the information for the properties. So I'm going to, again, copy and paste the one I have prepared just for ease of use. We are going to have the property address, the price, the square meters, the legal identifier, the document hash, the property state. This state is going to be enum. The verifier, if the address of who verified this property to have some accountability, and the token URI. For this, I also need to create an enum of the property state. By default, the auto-completion is giving me pending, verify, and rejected, but I'm going to add a more complex system. So it's going to be initial offering, for sale, pending sale, sold, and not for sale. And as I said, I need to also create a new mapping of the properties. So I'm going to map the token ID to the actual property details. So the mapping is going to be from a uint256 to a property object, which is this struct we have over here. With that, we can return back here and we don't have that complaints anymore, but we need to actually apply this over here. So I'm just going to say, this is going to be really obvious actually, because I just need to set that information up, the property address, the price, the square meters, the legal identifier, etc., etc. And all the properties are going to start at initial offering. After that, I want to actually emit a new event. So I'm going to say emit property created with all that information of the property, and I'm going to return the token ID. Again, I don't have the event created, so I'm going to make here a space just on the top of the constructor for the events. And I'm going to set that property created, but it seems that is matter to me because the amount of parameters I'm using is not the same. So it seems that I'm sending too much information. Actually, I just need this, the token ID, the property address, and the price. So I'm going to delete this, go back to the top and change the function to just use that. So I'm going to delete this and this, add the semicolon here, save. And if I go back to my terminal and run Forge compile, everything should work fine. And it does. So let's continue. Now that I have the ability to mint new properties, I need a way to actually verify those properties. However, the token URI is not going to be set to begin with, because when we save mint, we are just, creating the property but with no token URI. And the token URI is going to be important because it's going to be the one to store the actual image of the NFT or the property. So after that, I'm going to create a new function here called function set token URI. It's going to receive a UN256 with the token ID and string memory of the new token URI. It's going to be an external function, and I'm going to first verify if the property actually exists. So I'm going to say require exists token ID, and if not, I'm going to say the property does not exist. And I'm going to also require that the owner of the token ID is going to be equal to the message.sender, and I'm going to say that only the token owner is able to change the token URI. As you can see, I don't have this exist function, so I'm going to go to the top, maybe here, and I'm going to change that. So exists function. So function exists, it's going to be a UN256. It's going to require the token ID. It's going to be an internal view, and it's going to return a Boolean. And I'm just going to say the autocompletion didn't work this time, because what I'm going to say is, and here I'm going to say return owner of token ID is not, or is different from the address 0. So if the owner is different from the address 0, that means that that token actually exists because it has an owner. And remember that each time we create a new property, we have an initial owner, or the creator only can be the owner. So of course it needs to have our owner in order to exist. So now that I have this, I'm going to update the properties with the token ID, and I'm going to change the token URI to be the new token URI I'm sending as parameter. And I'm going to also emit a new event called token URI updated, and I'm going to emit the token ID and the new token URI. Again, this event does not exist, so I'm going to go to the top and create that event over here. Now that we have the ability to create a property and to set the token URI, let's create a function to verify the property. So for that, I'm going to say function verify property is going to take as the parameter the token ID of that property. So UN256 token ID is going to be, once again, an external function, and here we are going to add some logic. So first I'm going to add some required statements. The first required statement is that the wallet I'm using to verify this transaction or this property should be an approved verifier. So I'm going to go to the mapping approved verifiers, and the address should appear here. Remember that we can add a new verifier using the add verifier, which also modifies this mapping. So first, let's verify if the actual address we are using to verify is an approved verifier. Then I need to see if the property exists. So again, I'm going to use the exist function, and then I'm going to check if the property isn't already verified, because otherwise makes no sense, right? After all these comprobations, I'm going to set the property verifier to the message.sender. If you remember, our property struct has this address verifier. Again, this is important because if we want to blame, or at least point accountability on who was the responsible for verifying this, we are going to update that. If you are creating a real estate agency, when a user or an employee creates an account, you should create a server wallet in their behalf, and that server wallet is going to be attached to their profile. So when you check this out, you can also check who was the one verifying that property and why. And finally, I'm going to emit a new event called property property verified, and same as I did before, let's go back to the top where are my events, and let's add that event over here. Now, maybe you are wondering, is this the only thing you need for the verifying the property? We are actually not changing the state of any quote-unquote verification state, right? But we don't need to, because if the property construct or the property object has a verifier, it means that it was verified. Otherwise, this address is going to be address 0, meaning that the property wasn't verified. So we don't need to add any other logic on this function. Now I'm going to create some getter functions. So getters for getting the information out of this smart contract, and these are going to be quite simple. First, I'm going to create a getter to get a property based on the ID. So I'm going to say function get property. It's going to be a function that also takes the token ID, as I said. So token ID is going to be an external view and is going to return the property object as memory. And inside of here, I'm just going to say again, please be sure that the property exists, otherwise will make no sense. And then I'm just going to return the properties on the properties mapping with the ID I'm sending as parameter. Then I'm going to create another getter to get all the properties at once. So I'm going to say function get all properties. It's going to be external view returns, and it's going to return a property array because it could be one or more properties. And inside of here, I'm going to create a new property array. This property array is going to be memory, all properties equals to new property and the token IDs I'm sending and the token IDs. So I'm going to say for uint 256 equals to 1, and this variable being greater or less than the token IDs, please add 1. And here I'm going to say all properties and the index -1 equals to the properties I. And I'm going to return all properties. And as it says that, I'm going to have the ability to get all the properties. Finally, this is part I'm just going to copy and paste. I'm going to have these extra functions. These extra functions we are not going to be implementing or during the tutorial, but I'm going to leave them for you if you want to use this project as template. So those functions are going to be to change the state of the property. Remember that the initial state is initial offering, but if you are going to change this during the buying process, of course you need to update the state, and also the ability to bid or ask for buying this property and actually to complete the purchase. So the first function is going to be the one to update the property state. It also emits these events. So I'm going to go to the top and add those events. This one is just only to update the property state, as I said. And the last two functions are going to be the ones for actually being able to complete the purchase of the property. So first function is going to be require or request purchase. It's going to require that the property is actually for sale and is not on an initial phase. It's going to also require that the verifier doesn't have an address 0. That means that the property was properly verified. It's going to also require that the value sending to buy the property is enough, otherwise it's going to say that is the efficient payment. And this pending purchase is going to be a new struct with the information, so I'm going to also add that below this struct pending purchases, the buyer, the amount, and verify if actually exists again. And I'm going to add a mapping to map from the uint 256 to the pending purchases to understand, what's going to be the token ID, which is required to be purchased. And finally, I'm going to emit these events. And finally, the last function we need to implement over here is going to be the one for completing the purchase. So I'm going to also add that over here. Function complete purchase is going to require the token ID, a boolean to know if the operation was successful, the string memory and the reason the operation was successful. And we are going to first require that the purchase is not pending for purchase. I'm going to set the buyer to the buyer, the amount, and the token ID. I'm going to delete the pending purchase because once the purchase has completed, the property is not anymore a pending purchase. If the process is a success, we are going to do something, or otherwise, we are going to say that the payment failed. And I'm going to also change the state to property sold. And that's all the things we need for this smart contract. And I also added a bunch of new events: purchase requested, purchase completed, purchase sold, and purchase failed. And all of these events, well, I need to also add them on my events section. Otherwise, the compiler is going to be really mad at me. So let's go back again to the events. And here, let's add all of them: purchase requested, purchase completed, purchase failed. And one final event for the property sold. And as easy as that, I think we have everything we need. Let's check this out. And it seems that the property listed requires one more input parameter, which is going to be the price, property address, and token ID. So I think that's it. I can save this, go back to my terminal, and actually try to compile this again. And everything should work fine. And okay, that's it. That's the completion of all the steps we wanted. So let's go back to the code actually, and let's see if we actually completed everything we wanted. So let me open the README MD. We created a ERC 721 contract. This is completed. We add the functionality to add or remove verifiers. This is also completed. We added the function to verify the property. We added the bonus functions to request the purchase and actually complete the purchase of the property. And we added some getters to get information out of this smart contract. As I did everything here manually, it might be confusing for you. So I have a version 2 or a second version of this exact same contract. I'm going to just replace. It's the exact same as we did, but it's full of not spec documentation and comments. So you are going to know exactly what function does. Again, I hope you want to use this as template. So I'm going to save everything, try to compile one last time. And as everything works successfully, let's actually deploy this contract. Now we have different options. We can do the traditional way, which is just like going to the main project folder and creating a scripts and create or deploy a script. But as we are using Thirdweb, this is going to be way easier for us. Let's go back to my terminal and I'm going to say, let me clean it, npx Thirdweb deploy -k. Here I need to set up my private key. Be sure not to share this with anyone. But once I hit enter, this is going to start doing some magic on behind. Basically, it's going to tell me, hey, which contract you want to deploy? In my case, I want to deploy Real Estate RWA. Let's hit on enter, and this should open a web browser for me. And here on my web browser is going to ask me which project I want to use. I want to use Engine Cloud project, which is going to be the network I'm going to be deploying to. It's going to be Arbitrum Cephali because it's really cheap. I'm going to hit on deploy now. This should deploy the contract for me. And after some time, I'm going to be able to view my contract and have the dashboard with all the information of my recently deployed NFT contract. Be sure to copy this contract address because it's going to be really important on the next steps. Now, as I show you on the demo, we want the admin to be able to create new properties with all the information required. And as I said, everything should happen on the background or on the backend. So for that, as all the functions on our contract are only owner, right now the wallet or the unique responsible for doing this is the wallet we have connected over here. But we want the backend wallet to be the responsible, right? So let me go to the Explorer tab, go to Transfer Ownership, and here we are going to put the address of the owner. So for that, let me open a new tab with my projects. I'm going to go to Engine Cloud, go back again to the Engine tab, select Server Wallets, And here I'm going to use this RWA, or my trading wallet, sorry, as the owner. So I'm going to copy this address, go back to the Explorer, paste it, click on execute. This is going to trigger a transaction. I'm going to actually trigger it one more time. I hoping this to fail, and yes, it's failing because the last transaction was successful and now the owner is no longer me, but the actual server wallet we just set up. So now this server wallet is going to have complete ownership out of this contract. And with that said, we just finished the coding of the smart contract for this part of the tutorial. Let's continue on how we can integrate the ability to use the simple HTTP API to actually declare a new server wallet and execute the transactions from this smart contract. So let's jump to that. So for that, on my main folder, the same one I have the contracts, I'm going to just return one. And here I'm going to say boon create bite. Hit enter. This is going to ask me what's going to be the project name. I'm going to say RWA agency, for example. We are going to be using React with TypeScript plus SWC. Now I can go to that folder, RWA agency, and just install the dependencies with boon install. And I can run this actually with boon dep. And if I open this, it's going to open a basic Byte plus React project, which with this simple counter. So first and first, as we want to use the Thirdweb SDK in order to be able to use the server wallet, we need to add the Thirdweb capabilities or the Thirdweb grabber on this project. So for that, let's do the following. Let's go back to my code, but actually I just run the server, but I didn't open a new instance of Cursor here. So let me actually close this, and I'm going to say cursor dot. This is going to open a new instance of the editor. Let me make it bigger for you to be able to see it properly. And I'm going to go here to the src, and I'm going to create a new file here called client.ts. Here I'm going to say import create Thirdweb client from Thirdweb. And it's going to be mad at me, first because I'm not using this declaration, but also because we don't have Thirdweb installed. So let me go back to my terminal, and I'm going to say boon install Thirdweb. Let's leave that working. On the meantime, I'm going to use const client. It's going to be equal to import.meta.emp.bite Thirdweb client ID. And if I don't have it, I'm just going to leave it empty. And const secret key equals to import meta.emp bite Thirdweb secret key. With that information, I'm going to create a new client. So I'm going to say export const client equals to create Thirdweb client, and I'm going to be sending the client ID, but here actually it should be client ID in order to prevent this. And as easy as that, we have the client. If you go back to your server over here and you check the documentation, you are going to see that if you want to use the SDK, we need to create a Thirdweb client and we need to send the secret key. The reason I'm doing this over here and also sending the client ID is because we are building a front-end application. So this client is going to serve two purposes: the ability to grab our entire application using Thirdweb for the front-end, and the secret key is going to be the one we are going to use to declare the server wallet, and with that perform the transactions. Also, I'm using this information because I want to store all of this on a new .env file. So here I need to use this Thirdweb client ID and also this Thirdweb client secret, and I need to get this from my dashboard. And remember, at the beginning of the video, we created a new project, and all of this information, we already have it. We just need to add it here. Here I'm going to also create a env.t.ts, and I'm going to import the meta information from the Thirdweb client ID, Thirdweb's wallet address, Vault access token, and the RWA deployed contract address, the contract we just deployed. And we are going to import the meta env to be read only. Basically, we are preventing this to be overridden or manipulated. This is not the most secure practice, basically because using .envs is a bad practice, because if you forget to add this to your git ignore configuration, well, you are screwed, especially if you are sending private keys over here for your wallets. What's interesting about this is, let's suppose I screw it up, somehow I forget to add this to my git ignore. Everyone is going to have access to my vault and my wallets, right? That's technically true, but you can just go to your admin panel and rotate the admin key. And as easy as that, you're going to be secure again. That's the magic of using Vault. Anyway, I must say that this is a tutorial and I want to make it as straightforward as possible, but using private information into .env files is not a good practice. I 100% recommend you to use a more secure base, such as a password manager, or at least encrypt your information. With that said, let's continue with the tutorial. So once we have that, we can go to our main.tsx and grab everything between the scope of the Thirdweb wrapper. So I can just say over here, please import the Thirdweb client, import the Thirdweb provider, sorry, from @Thirdweb. The code snippets the AA provide is outdated because there is no more @Thirdweb dev, but it's just Thirdweb-React. And I need to grab the app inside of that Thirdweb provider. And I don't need to set the client anymore, so I'm going to remove this, open this, and put the application inside. And as easy as that, that's the only thing I need. I'm going to actually separate this for visibility, but as easy as that, I should be able to use Thirdweb services here. So let's test this out. I'm going to go to my app.tsx, remove all the contents of it, and here I'm just going to, let me actually remove these and this, and I'm going to say import connect button from Thirdweb React, and here I need to create a new connect button, and of course I need to send to the connect button the client we are going to use. So I'm going to say connect button, and the client is going to be equal to client, and we don't have the client, so I need to import client from client, and the client we just declared over here, so this should work properly. Let's save everything. Let's go back to my terminal again. Where it is? Here it is. Let me clear this, and I can say boon step. This should open my application again, and as you can see here, we have this connect button. I already have my wallet connected, but I can disconnect this, and if this works, and it seems it's working, it seems that we have properly added the Thirdweb capabilities to our project. Then building the interface is going to be in two different parts. First, you can do the traditional part of coding yourself, or you can just use the AI agents we have nowadays and ask it for create the interface for you, or use an application really interesting such as B0 from Vercel that allow you to build beautiful interfaces from scratch. In that case, what I'm going to focus my attention on is not going to be the actual interface, because you are going to find the interface as a template on the description, but I'm going to focus more on the part on how we can actually integrate the HTTP API for the backend server wallets in order to be able to perform transactions same as I show you at the beginning of the video, like being able to create a new property, how can we trigger that, how we can connect to the server wallet, and how we can set everything up to work seamlessly. I'm going to also show you how to get the information out of the deployed smart contract we just created. So we are going to have the basic functions to write to the smart contract or write to the blockchain, and also to read from the blockchain to get the information out of this. How the interface is going to look like depends a lot of how you are creating the actual look and feel of the front end. Let me go back to my code actually, and here on the src, I'm going to create a new folder called engine. And inside of engine, we are going to start adding all the functions we are going to need. So the first thing is going to be the RWA contract. So I'm going to say RWA contract.tsx. Remember, we just deployed a smart contract over here with this address, and we need the ability to get information out of the contract because this is the one we want to interact with. So I'm going to create just a simple script to get information out of that contract or to declare that contract. So for that, I'm going to say import get contract is going to be from Thirdweb. I'm going to also import the client from the client file. Let me remove this auto completion. I don't need this for now. And I'm going to import Arbitrum because it's the chain we used to deploy this contract. So we need to also use that. So I'm just going to say export const RWA contract is going to be equal to get contract. And I'm going to open brackets over here. I'm going to send as parameter the client. The chain is going to be Arbitrum and the address is going to be import meta.m.bter RWA deployed contract address. Again, you just need to add this to your .m file in order to be able to access this information right away. Remember that you can always go back to the contract you deployed and copy the address, and this is the address we need to use. As this is that, we have our first script created for the front end, so we can continue. Let me go back to my code editor, and the next file we are going to create is the server wallet itself. So I'm going to open here and I'm going to say server wallet.tsx. This is the new part. If you haven't ever used it, if you already have used Thirdweb on the past, this is the part that is going to be new for you because this is part of the new service and it's going to be as easy as it was before. Again, I'm going to import the client and I'm going to import this new package called engine from Thirdweb. And I'm going to also import engine from Thirdweb. And here I'm just going to say export const server wallet is going to be equal to engine.create wallet. I'm going to open brackets over here and I'm going to again send the client. The address is going to be import.meta.bter server wallet address. For that, you need to go to your application dashboard, go to the server wallets, copy this wallet address and paste it in your .m file with this name to be able to access to it. And then also we are also going to need the vault access token, which is going to be, again, going back to your dashboard, going to Vault, and copy this access token. But you are supposed to already have this information, right? Because you copied that when we started this tutorial. Once I have that, the actual function I'm going to use is not create wallet, actually. The auto-completion was wrong, is server wallet, which is our new function. And as this is that, we have the contract and the wallet. With that information, we are ready to perform our first transaction, or at least set up this to be able to perform the first transaction. And the transaction I want to perform is the ability to create a new property, or AKA mint a new NFT. So for that, I'm going to create a new file inside of Engine called mint new asset.tsx. Here I'm going to import prepare contract call and engine from Thirdweb. I'm going to import the server wallet, the RWA contract, and the client. Again, if you get lost at any point, you can just go back to the API Explorer, and as you can see, what we did is the exact same. We created a new client or a Thirdweb client, but we did it globally because we are building a front end. We declared the chain, we created a new client, we declared a new server wallet, and then we need to create the transaction information. In this case, as this is using the extension, the function here is using is claim2, but as we created our own custom ERC721 contract, we can just use the prepare contract call functionality from the SDK, as you can see here, and I can just create the transaction and send the transaction method we are going to use. We already know what's the function we want to use. In this case, we want to use the function on our smart contract called create property, and we already know all the parameters we need to send to that function. So for that, let's go back to the other code editor over here, this one, and here let's continue. So I'm going to say export const create new property. It's going to be equal to async, open parentheses, property address is going to be a string, the price is going to be a big int. The reason is because Solidity uses these big ints, so we need to respect that. The square meters is going to also be not a big int, but actually a number. The legal identifier is going to be equal to a string. The document URI, or the document hash actually, the one we are going to be uploading to IPFS, and the image URI, string, comma. Again, I'm just taking the parameters from my smart contract, property address, price, square meters, like identifier, document hash, and image URI. And these are the ones I also need to send. So here I'm going to say this actually equals to a function, and inside of this function we are going to say console.log creating a new property. This console log is not needed, but I'm just going to do it like, for good practice. And I'm going to say try, and I'm going to declare the transaction. So I'm going to say const transaction is going to be equal to prepare contract call. This is from Thirdweb SDK, the one we just imported over here, the prepare contract call. I'm going to open this, and inside of here, I'm going to say the contract is going to be equal to the RWA contract. The method is going to be the function create property, and this is going to receive a string, a u into 56, a u into 56, another string, and another string. How do I know all of this? Well, I just checked my contract, and I'm just using string, uint, string. That's the same, and this is the format we need to use. When we use this, actually what we are doing is kinda declaring the contract ABI, or the function signature, which is similar to the ABI. And that's why we need to set up all the input parameters this function receives. Then I need to send the params I'm going to send to this function. So I'm going to say, I'm going to send these parameters, and I'm going to use all the parameters we just declared on the top. And here I set contract equal, but it's actually contract 2 points. And I think that square meters are not spelled correctly, I guess. And it's saying that number is not assignable to big int, so I need to transform this also to a big int. Okay, makes sense. Let's continue. Let me add a semicolon here and a comma here, just as a good practice. Let me close this, and I think I have everything I need, right? Okay, so we need to close this try catch statement. So I'm going to say catch error and just console.log the error if anything goes wrong. Once we have declared the transaction, we are going to try to actually execute that transaction. So I'm going to create a new try catch statement inside of here. And I'm going to say try catch error console.error unable to perform the transaction. And inside of this try catch statement, let's try to actually execute the transaction as I said. So for that, I'm going to say const transaction ID is going to be equal to await server wallet dot queue transaction and the transaction object we just created. And as it says that, we are going to have a transaction ID. We are not going to get the specific transaction hash yet. Remember, because when we send a new transaction to the actual engine, let me find the tab over here. Each new transaction is going to have a unique identifier. This is made because if you have 20 users and 20 users want at the same time to use your wallet or the backend wallet to perform a transaction, in order to be able to do that, instead of trying to execute the transactions all at once, they are going to be queued, and then on the backend, Engine Cloud is going to be the responsible to execute them. So that's why we have this queue ID or transaction ID. But once this transaction is finished, it means that we need to wait until this transaction to be performed properly. We are going to have the transaction details or the transaction result. So I can say const execution result is going to be equal to await engine dot get transaction status, and here I'm going to send the client and the transaction ID. And this if else is not necessary here. It was the auto completion, but not necessary at all. Once we have the execution result, if the execution was successful, it means that now we are going to actually have a transaction hash. So here I can say const transaction hash is going to be equal to await engine dot wait for transaction hash. And again, I need to send the client and the transaction ID. And finally, I want to return this transaction hash. This transaction hash is going to be important because this is the one I'm going to show to my user when, everything goes fine. Now it's telling me that the execution result is not being used. For that, actually, let me just console.log that. This is not necessarily 100%, but because I'm making a tutorial and I want you to be able to show this in action, I'm also using this execution result. And as easy as that, I think we have everything we need for this specific part. So what I need to do right now is to create the component which is going to allow me to interact with this and see if everything is working properly. So for that, let's take advantage of the vibe coding. Let me put myself on a different part of the screen. And as you can see here, I have the chat input interface for cursor, and I'm going to use the agent mode, and I'm going to use Cloud 3.7 Sonnet for this. So here on the SRC folder, I'm going to create a new folder called components, and I can say, hey, please create a new component based on this code inside of the components folder. It must be a simple form to create a new NFT. For the image URI, you need to allow the user to upload an actual image, and for the document hash, the same. For the document hash, a document. And as we want to be able to use an actual image and an actual document, what it needs to happen is that our application should transform this information, upload it to the IPFS, and then we are going to get back a IPFS hash out of for the image, which is going to be used for the token URI, and for the document or the deed. So for that, let me show you one interesting thing you can do using Cursor. I'm going to open a new tab on my browser, and I'm going to say Thirdweb storage docs. Here I have this information on how to upload files to IPFS. It's telling me how to do it from the interface, but I want to use the SDK. And as I have here the code snippets, I can actually just copy this, go back to my cursor, which is this one, use this documentation to know how to upload information to IPFS using Thirdweb. Let's hit enter and let's see what happens. It's going to try and understand the request I just made, and it's going to try to create this component for me. So let's wait a little bit. So it created this file called create property form. It created a lot of states. It's nice. It seems that it encounters some linter errors, so I hope it's going to fix them automatically. And it seems, and as you can see, it encountered a lot of problems, like because the code snippets are usually outdated on these AI models. It used an old version of Thirdweb, but it seems that it encountered that error, looked on the internet to know what are the correct snippets for Thirdweb v5, corrected itself, and is actually creating the form CSS. I didn't ask for this, but it's nice to see that it's going to also create its own styles. And now it's going to also update the app.tsx to include our new component. Again, I didn't ask for this, but it's nice to have, especially because we want to test this out. Let's let's wait a little bit until this finishes actually. It's taking a little bit longer than I expected, but it's nice because it's saving us all the time to create the component for the front end, because the important part we already did. We manually created the script we need to create or execute a new transaction using the server wallet, and right now the actual interface, again, is not that important or relevant. It seems that it finished it, so I can click on accept all, and we can open my web browser, go back to the application, and it seems it created this information over here. And let's be honest, it looks ugly because we didn't install any libraries such as Tailwind or Material UI, but it seems it works. I can input the address, the price in weight, the square meters, the legal identifier. We can send the property of the image, and we can also upload the local document, and it seems that everything is going to work. But before I click on create property, what I'm actually going to do is to modify a little bit my code. I actually already did, just to add more comments, and I added a bunch of console.logs for you to know what's happening at any point of this transaction. So I just added, again, same logic as before. The only difference is that I added comments and a console.log all the way long during this script. So with that said, let's go back here. Let's create a new property again. I'm going to just embed information because it's not that important. I'm going to choose file here, for example, the document, this one. And I'm going to actually make this as big as possible for you to be able to see. And let's click on create property. So what it's going to do here is going to create in property. This is the information is sending as parameter with the information over here, the document hash, the image URI. It's still E because I'm uploading this. The transaction was prepared successfully. The server wallet address before transaction is the one we set up on our engine. The contract address is the one we just deployed. We are going to send in the transaction using the account. As you can see, the server wallet and the account sending the transaction is the exact same. And the transaction is enqueued with this ID. Then we wait for that transaction details, and we have the information over here, and the status is queued. And as you can see here, as we requested, this is printing the transaction hash for us. So I can copy this transaction hash, open the Sefolia RB scan, and paste this transaction hash over here. And as you can see here, we minted a new ERC721 token for the real estate contract we created along the way. We can also go back to our engine. Let me check this, and 1 minute ago, we created this transaction, which is the exact same. If you check this, you are going to see that. Let me actually go back and get the transaction hash. And as you can see, this transaction is the exact same one as this one, ending on 00EBD, 00EBD. So we can get to the transaction hash directly from the interface. So it was really nice. As you saw, what we did is just declaring first the server wallet, then the RWA contract or the contract we want to interact with. And it was as easy as to create or prepare a contract call and then just call the server wallet.enqueue transaction to send the transaction. Then we retrieve the transaction status. At the end, we return the transaction hash. This was really nice. What's left for this interface is, okay, again, this interface looks just really, really ugly if you ask me. I'm not going to say that the example interface looks nicer than this one, but at least it's more acceptable. So what you can do is go back to your cursor and open the chat and say, please change the interface and use the libraries of such as Tailwind CSS, Material UI, etc., etc. That's not relevant here, so I'm going to leave that to you. And also remember that this exact template with this interface is going to be on the description if you want to use this exact same template. With that said, let's continue with the actual functionalities of this. So I'm going to go back to my application.tsx and remove this create property form. Let's go back here. This should be removed. And I am also going to remove this connect button because I just added that, just to test the Thirdweb container, but I don't need it anymore. So now that I tested that I can create new properties, let's see how we can retrieve that information out of the blockchain. So for that, I'm going to create a new file here inside of Engine to retrieve those NFTs. So I'm going to say, let's create a new file on the Engine folder, which is going to be called get properties utils.tsx. And this is going to be really easy. Let's import again the RWA contract with uppercase C, and now we can start. So first I'm going to create a type for the contract. So I'm going to say export type property and the property with all the information. Again, I'm not going to be repeating myself over and over again, but we know the exact parameters because we created the smart contract, so we know what the interface of the property is going to look like. So for that, let's create a new function. I'm going to say export const get property. The token ID is going to be a big int, and this is going to be a promise because this is going to be used on another script. Inside of here, I'm going to actually, let me close the chat, and I'm going to say try. As always, let's add a catch here to catch any error. And I'm going to console.log any error that we might get. And inside of the try statement, I'm going to say const property is going to be equal to await read contract. And I'm going to say contract is going to be the RWA contract, and the method is going to be another function. And the function we created when we were developing this smart contract, which is going to be function get property, is going to receive a uint256, which is going to be the ID of the property, view returns, and I'm going to send all the parameters this property requires. So let me add that over here. And we also need to send the params, and the params this requires is the token ID. Once we get that information out of the blockchain or out of the smart contract, I need to convert the returned tuple to an object with named properties. This is basically because I want to use the export type property we just created over here. So what I can do is just say const property with name fields, property address equals to property on the index 1, property on the index 0, 1, 2, 3, 4, and so on and so forth until we get all the properties we need. And then I just need to return property with name fields. And as easy as that, we have the ability to retrieve the property. And I'm having this error here telling me that the function lacks ending return statement and return type does not include undefined. And I think the reason is because I need to be more consistent here on the error. So I'm going to say here console.error and throw the error. And if that's true, okay, this is solved. So we need the next function, as I said, to get all the properties, same as we have on our smart contract. So I'm going to just add that right away. So another function, export const get all properties. It's going to be again a promise, asynchronous. It's going to return a property object, but this time is going to be an array of properties. I'm going to again say read contract. I'm going to read the function get all properties. I'm not going to send any params because if we check this out, or get all properties inside the real estate contract doesn't require any parameter. So I'm going to use the exact same logic. I'm going to map all the responses and I'm going to return an object or add a new property object to the array for each one of the properties I get. And same as we did before, I'm going to open my chat interface over here. Let me actually change the context over here and use the context get properties utils. Now please create a card component for each one of the component for the NFT of a property and a gallery component with all the NFTs. Here we're going to have a small problem with the IPFS endpoint. I'm going to show you afterwards. So let's just hit enter and let's see what happens. It seems it's almost finished. It's going to also try and add the gallery to my app.tsx, which is quite useful. Let's wait a little bit more until it updates all the styles and the components, and let's see what happens. So it seems it finished. So let's go back to the application, and it seems that it's not working anymore, but the reason is because, as I said, it's trying to use this specifically IPFS problem. And as I said, this is problematic because browsers are not able, and React is not able to manage IPFS addresses. So what I need to do is going back to actually my projects, and here I can go to usage. Inside of usage, I have this RPC, no, I have this storage tab, and I have all the files I uploaded, but I have here the IPFS gateway. So I can copy this and say, I'm going to copy this error, taking a screenshot, go back to the editor, and I'm going to say, I'm getting errors at loading the IPFS information because you are using a incorrect gateway. You need to use this one and the one I'm sending, and the client ID is on the emp file under the name. I don't actually remember the name I used, so I can check this. It's called Bitted Thirdweb client ID. Let's hit enter and let's wait a little bit more. After this is processed, I can go back to my web app, and as you can see here, I have the information actually, and I have Evergreen Venue, the one we created at the beginning, and this other one I created within the examples. Again, I'm having some errors with the proper token URI because I'm sure it's trying to render the token URI directly instead of opening the token URI and getting the object from the image itself. But as you can see here, it worked. It allowed me to actually get the information and get those NFTs out of the blockchain. What's left from this? Well, we need to debug this. So we have two options: go to the actual card and try to do what I said, change the IPFS gateway to actually get the token URI, open that token URI, and afterwards get the image, or just tinkering with the AI until we get the response we wanted. At this point, I think I showed you everything you need to know to create and build this. Take in consideration that this user interface you see here is mostly AI as well. I vibe coded most of this user interface until I get the responses I wanted, but the important part for you to learn out of this, we already did it. Let's make a small recap. We created a new server wallet, which is using the engine server wallets. We declared this contract we are going to be interacting with. We created a new function to mint the new properties or the new NFTs, and we created a new util to get the properties information. Now we can create a new util, for example, to get or to verify, to add the verifiers and to actually verify the properties. We can do it manually, but let me show you something interesting that you also can achieve using AI. What I'm going to do is that, as you can see here, I have the contract folder, and something interesting we can do is take the contract folder and insert it inside of the actual project folder. So once we have that, the AI is going to have access to the contract. So I can go back here, let me remove this, and I can say, hey, take a look to add RWA real estate.sol, because it's already here in the source folder. Please create a new file / script for each one of the missing implementations we have on Engine. We already have the ability to get the NFTs on at get property utils and the ability to create a new property on mint new asset. We need the rest. We need the rest of the scripts for the missing functions on the contract. Please create a individual script for each one. And I'm going to hit enter, and this is going to analyze the contract code and is going to try and create a new function for each one of the missing parts. So it's going to, list all of them. Let me actually make this bigger for you to see. And it's going to create a set of TypeScript files to implement the missing contract functions. So for example, the first one it's trying to add is add verifier. So as you can see here, I have the add verifier function. And as we already created and used as reference the server wallet, the contract, and the prepare contract call here on the mint new asset, the AI is going to look at this file, use this as reference, and is going to create this one to interact with this smart contract. And as you can see here, one by one, it's going to start adding those missing features. Let me show you the other project I have here, the one I made before this project or before this video. And as you can see here, we have all the functionalities. At some point, I did the exact same. I created these functions manually. And then for the rest ones, I just said, hey, take a look to the contract and use this as reference and create the rest functions for me. Once the functions were created, I opened a new chat and I asked, please, let me actually remove this. Please create a new component for each one of these. And I had at the end these components. Remove verifier, refresh button, verify property button, the NFT gallery, etc., etc. And then I just put everything together on the app.tsx using Material UI, and it led me to have the final result I showed you at the beginning of the video. This is great because now using some vibe coding and actually understanding the project structure, you can build a nice user interface in matter of minutes. My recommendation for you is to create the first functions or the first functionalities manually, and then just ask the AI to complete the rest for you. So we have the ability to create a new property, add a new verifier. These verifiers are the other backend wallet address, verify a property, and here we have the property information. And that was it for today's video. We were able to deploy a new instance of Engine Cloud, creating different server wallets. We created a really nice smart contract for a real-world tokenized asset, and we created the system for this real estate agency to be able to perform all the transactions on the backend. I show you how you can retrieve that information out of the blockchain and how to trigger those transactions on your application. Remember that the template with the exact code used for this and the exact user interface is going to be on the description. But if you followed along and you have the older quote-unquote uglier version, the challenge for you is to transform that to a nice looking interface using AI or coding yourself manually. But now you have all the foundations you needed. You know how to deploy an engine and use backend wallets. You have the ability to create the smart contract and personalize it as much as you like. You know how to create a new server wallet declaration on the front end and how to trigger transactions using the API. That's all I have for you today. I really hope you enjoyed this video. Please like and subscribe to the channel if you haven't already, and I'll see you on the next video tutorial. See ya!